Now that we have Python installed and PyCharm up and running, it's time for us to create our first real project in it. If you open up PyCharm, you should see a window that looks like this. On the left-hand side, you'll see all the projects you've created before that you can open and access. You might have an empty list here. So we need to create a new project to get things up and running. When I press this, I get to this screen here. The first thing I want to do is set the location where I save my project. And I highly recommend you have a common spot that you save your projects. I store mine under my OneDrive, under our Python projects folder. The next thing that we're going to make sure of is that we're using an environment for our project. And we're going to prioritize the virtual environment in this course. This is going to create kind of a standalone place that we can install plugins, that we can input or include libraries in, as well as write and run our Python code independent of the console, so that it's nice and organized in one spot. Basically, it just packages everything up to be managed, everything we need for Python, and all the things that we extend into it, all in one place. And let it choose a location automatically based off of the original folder that you chose above. And we are going to allow it to create a welcome script for us so that we have at least something made to start writing in right off the bat. Now I'm going to press create. And my project is now loading. This virtual environment is going to be run up, meaning that it's actually creating a whole other kind of workspace for our current project. And when we create projects this way, every project that you make will have its own custom virtual environment built just for that project to allow it to be an independent and unique workspace for the code that you're going to be writing and running for that particular need. It takes a tiny bit of time to load up here, and so I'll show you a couple things. If it allows me to click, oh, it doesn't allow me to click. And should be almost done, but a quick tour of our menu in PyCharm here. At the top, we have access to all of our normal directories, but on the bottom, we have access to a few different terminal windows. We have our to-do list, which we aren't going to be working with much in this project at all. We have problems where you'll see error messages and other types of debugging outputs popping up. You have a terminal that you could use, kind of like walking into the Windows terminal, but this is a terminal for our virtual environment itself, allowing us to import and install and kind of give commands for how we want to work in this virtual environment. And then the Python console itself, which we're able to actually run kind of scripts of Python code inside of our environment if we'd like. But for now, we're going to kind of ignore all these environments and just take a look at the project which has finally been built for us and what it is that we're seeing on the screen. First of all, on the left, we see our root directory folder that has this venv folder. This stands for the virtual environment. Now, if we expand this out, we'll see that it has this includes folder, which is basically just a master resource list of all of the things that our project needs to include. This is all pre-built into our virtual environment that we don't need to mess with. But inside of it, it comes with some libraries that allow the environment to run properly, and some scripts that are things that we might interact with a bit later in the course as we do some custom imports using this thing called pip, which is the package manager within our virtual environment. For the most part, we actually aren't even going to bother looking in this folder much at all. However, we do see that our main Python file is stored kind of within this subheading. And if we want to create more Python files, we'll right-click on this venv and add new Python files in here. But for us, we already have a main created. A quick note about what we see down here, these external libraries just hold a whole bunch of kind of pre-packaged and core root libraries that Python comes built with that allows Python to function in the first place, as well as allows us to do some cool basic functionality right out of the box in Python. And once again, we're not really going to mess with that directly, but it is present in every project that we make to be ready for us to work with. And now, let's take a look at our actual main Python file. We have some setup types of information that get automatically built in here that print out a simple message. We'll talk about this type of syntax and way of working with different types of main functionality. If you remember studying Java last year, then you remember that we had a main method, and this is kind of a main method as well in the style of Python, but we actually don't need any of this to run a program in Python. It's useful in certain contexts, but in what we're doing right now in our learning and just trying to test things out, it's easier if we just delete all of this and start with a blank slate. So here we go. I'm going to delete all of it, have my blank slate, and let's take a look at a few brief things we can do to start thinking about how we write code in Python. The first thing that I want to show you is how to write a comment. In Python, we use the pound symbol or the hashtag symbol, and everything after this won't be read as code. This is a comment. For multi-line comments, we typically just kind of put one of these on each line and continue writing line 2, line 3, and so on and so forth for multi-line comments. You technically are able to put a triple quotation, and then anything inside of this could be this is a multi-line comment as well. Everything in between these could be a comment. You get to decide what you prefer for the different commenting styles in Python, but none of this will be read as actual code in the Python program. It's all just basic comments. The next thing I want to show you is that we are actually able to import different libraries from Python. And I have a few examples that I'll pull up on the side here that we might want to be using to give us some extra functionality in how we work with our Python programs. The standard library of Python has a whole bunch of solutions to things that have been written by other coders that we can take advantage of in our programs. So we don't have to resolve classic problems that have already been unraveled. For example, a randomizer. If we import random, what we're doing is we're pulling into our library of functionality this class basically that's full of functionality of a randomizer. And now down, I'm going to erase this comment down here. If I type in random and dot, I will see in PyCharm all of the functionality that's built in this randomizer, things that allow me to get some random numbers or information from a sequence and a whole bunch of other different subsets of randomized data that we can access just really easily and directly through this random import. I could also consider importing the math class, which can be really useful. Now, if I type in math, I have the ability to run a whole bunch of different formulas, things like trigonometry and exponential functions and all sorts of other logarithms and powers and some beautiful stuff to perform different math calculations if I need to. I don't have to write custom code to perform those calculations. It's just right here inside of the imported options. Now, in Python, we have a bunch of built-in functions. And a website like this documentation on the Python site show us the built-in functions that we don't even have to import. So this whole process of importing math, some functionality just comes straight out of the box with Python. And some of the most common ones that we'll be using would be like this print statement, which in the documentation explains how it works. But really, what all this is doing is that anything that I put inside of it will be output to the console. And this is the perfect place to actually begin writing some custom Python code. I'm going to type hello world inside of this, making sure that I put these apostrophes beside it to tell my program that it's a string. And I can go up to this run button or press Shift F10 as a shortcut, and now I will see the run console pop up and print hello world to my console. So this command print comes right out of the box. If you want to remember Java last year, we had to do this whole system.out.print line and then the message in here with a semicolon at the end. This is the Java commenting. I'll make it the Python commenting since we're writing in Python right now. This is the whole message that was needed for Java. In Python, it's much more straightforward. We literally just say print and hello world. And for those who have done a lot of Java in the past, you'll notice I don't need this semicolon. Python doesn't manage its syntax and style with all this extra punctuation. We need some. We still need these brackets for the method call. We still need these apostrophes to show it's a string, but no semicolon required. We also avoid a lot of these squigglies. They are useful at times, but generally speaking, when we have content inside of something else, we use indentation and space to determine it. But we'll see more about that in a lesson to come. Let's dive back over here to some of our main built-in functions. Another big one that we'll be using soon is the type function, which actually will report to us the type of variable or data that we're working with. Another one that you might be interested in is len, which stands for length. It allows us to put an object inside of it, and it will tell us how long that object is. There's a lot of really nice, short and sweet built-in pieces of functionality, powers, rounding numbers, getting to absolute value, different types of character changes and character manipulation, and all sorts of different things that manage data, different types of numbers, lists and organization, all sorts of things that are built right in it'd be a good idea to save a link to this built-in functions page and maybe take some time to browse through it to see what's built into Python that you can use really easily right out of the box. We also have documentation that's stored at the pymodindex.html part of the Python main website. This documentation shows you the standard library, which are all of the different imports that you can do and use right out of the box in the standard library to import into your project. So this is where we get the import random, this is where we get the import math, and there's lots of other ones that you can use for different types of functionality. And let's say you want to use the math one, following the site's link in the API, you're able to see all of the different methods inside of this that you can then read about how these methods function. It's going to be a little bit different in terms of how they're built than they were done in Java, but I'll teach you more about how we can read information about methods in a few tutorials down the line from now. But for now, just be aware it exists and maybe take a peek if you're curious. So, what have we learned in this lesson? Well, how to set up a Python project, how to get things up and running in PyCharm, how to write basic comments, the idea of importing external libraries, and how to use some of our basic standard library to print a little bit of information out to the user.